balance measurement, we are having equal beam scale, equal equal beam balance scale. Then second one we will discuss it, unequal beam unequal beam balance. Then multi-lever, third one is multi-lever lever. Then multi-lever platform scale. Then pendulum, another one is a pendulum. So these are nothing but these are scale and balance type of force measurement. It is totally depend upon the weight. If I have considered the equal beam type of balance measurement, in that particular aspect, we are having the two weights. One is known weight and another one is the unknown weight. And we are trying to compare that unknown weight with the standard weight. In unequal balance measurement, actually we are having one of the unequal weight and the scale is managed in such a manner that we people are going to get the resultant output depending upon the power scale which is associated. And in multi-lever it consists of multiple points for the adjustment of the weight depending upon the distance or the length that has been taken under consideration. And in inverted pendulum one, as your balance matches, your inverted pendulum will try to hold the condition at one particular position as a point. So this was the concept that was related to your scale and balance type of weight measurement. Okay, so the other points which are supposed to be discussed are, the second one is elastic force, and elastic force is associated with the spring type of this one. Okay, so in spring type, we are having one spring at the initial condition, and when we people are over here, if your weight is or mass or force is not exerted at that time, if at that time it will hold the condition, and if you have applied a force at that time you are going to exert a force, so the length has been increased over here depending on this one, and this particular length is calibrated in terms of a force. So how much length has been increased is totally depend upon the force that has been exerted on the or below the mass. Okay, so this is the concept that has been used or for spring type of uh, uh, force measurement. Okay, the another mean is your load cells, and in that particular load cells, we people are using the concept of strain gauge. I will represent this one as a strain gauge type of load cell, type of load cell. Second one is your hydraulic type of load cell. Then third one is a pneumatic type of load cell. And fourth one is linear variable differential transform. Okay, so in strain gauge, we people are using a Wheatstone bridge, and in this particular Wheatstone bridge, if suppose we have considered these two as a strain gauges, at that time, actually when all the resistance that is R1, R2, R3, R4 are equal, they are equal, at that instant, the bridge output which we people are going to get, that bridge output E0 will be null, will be null. And if suppose the output generated is not equal, at that time E0 will show some X voltage. So that principle of balance and unbalance has been used in strain gauge. We will go thoroughly for this particular topic. Then second one is the hydraulic one, and the example has been provided that when we people are using the external force that has been applied on the uh, piston, at that time the force will be exerted or the resultant output will be exerted. Suppose this is the piston, this is the piston, and here is the shaft. If we are applying a force on this one, over here we people are having some manometer. So by applying a pressure at this one, this oil will exert a pressure. So it will try to move in the upward direction. Here is our pressure gauge. It will indicate the value. So this pressure gauge value is calibrated in terms of force that has been applied on the oil or that has been exerted on the oil. Second one is your pneumatic type. Only the difference, instead of oil using over here, here we people are using a manometer. So this manometer is used, and again here diaphragm, actually here also diaphragm is used. Force has been applied from the top. Your ear will become a compress and it will try to increase the height. So this height is measured and the pressure difference P1 and P2 is measured and delta P has been determined. So by using the pressure formula, you people can use the sense of knowledge and convert that one into the applied force. So in the previous lecture, we people have completed all these constraints, and in this lecture, we are going to move in the detail of the various types of strain gauges and various types of means that are used for the measurement of force, not torque, but the force and torque also, because the common mean which we people are going to use is the strain gauge. We are going to thoroughly go through that strain gauge. So the contents are application of strain gauge, derivation of the strain gauge factor, overlook, we people will overlook on the derivation of the strain gauge, composition of the strain gauge material, bounded metal foil gauge, gauge length, baking material used, adhesive material, semiconductor strain gauge, and strain gauge in a Wheatstone bridge and temperature compensation. So after completion of this lecture, what knowledge you people are going to gain or what you people will be able to express after completion. So all these things you will be able to justify the application of the strain gauge. You will be able to derive the expression for the gauge factor. You people will able to state the composition based upon the material for the strain gauges. You people will be able to distinguish the bounded metal foil strain gauge, then gauge length, then baking material that has been used, adhesive material, different semiconductor strain gauge, and the use of strain gauge in a Wheatstone bridge and need of temperature compensation. These are the contents that you people will be able to understand and able to express after completing this lecture. That is nothing but these are the learning outcome of this particular lecture. Okay. So what are the topics that you people are going to study in this particular lecture is the force measurement using piezoelectric crystal, strain gauge and vibrating string. So in general, I will complete the piezoelectric because in strain gauge also piezoresistive material is used. But shortly, I will try to express you people regarding the piezoelectric type of sensor that has been used for the force measurement. So piezoelectric crystal is nothing but this is the piezoelectric crystal. So over here I have shown you the constructional detail of piezoelectric crystal. Now what is the property of piezoelectric crystal? That if we apply a force to the piezoelectric crystal, it will deform, generating a voltage in proportion to that of force applied to it, or else, sorry for inconvenience, it will not deform, but it will try to generate, this will try to generate a uh, applying a force, it will try to generate a voltage. And if you apply a voltage to the piezoelectric crystal, it will try to deform. Okay, and vice versa. So this is the piezoelectric crystal. From upper side and from lower side, if I try to apply a force, this is force, this is force that has been applied to piezoelectric crystal. Now how this is working, that I am representing. So across these particular points, few people are going to get a voltage E0. So depending upon the applied force, if you increase the applied force, so in proportion to the applied force, your voltage is going to be generated. If you decrease the applied voltage in proportion, it is going to decrease. So this is nothing but the output that has been generated depending upon the applied force. The force is the parameter which we people are interested to measure. Okay, so depending upon that particular parameter, here your voltage is going to generate and vice versa to this. But here we are interested to measure the force. So when we are applying a force on this particular piezoelectric crystal, it is going to generate the voltage that is directly proportional to the piezo applied force. Okay, so this one is the concept of piezoelectric crystal, based on which you can measure a force that has been applied. Vibrating string. In vibrating string, what happens? You people, if you apply